Bismillahirrahmanirrahim. Assalamu alaikum and hello to everyone. So in this lecture we are going to solve some examples related to the easy nomenclature. In the previous lecture I have discussed the two main types of nomenclature that are associated with the geometrical isomerism, that are cis-trans nomenclature and the easy nomenclature. So if you want to understand the core concept and how to assign the easy nomenclature from the very basic examples, you should watch the previous video. So in this lecture I have collected some complex examples, and we will try to solve them in this video to make you understand how to assign easy nomenclature. So let's start with the very first example. So before you solve all these examples, you must remember two main things. The first one is that the priority order, it is assigned on the basis of the atomic number. The one group which has the higher atomic number containing atom, it has the highest priority. And the second point which you must remember is that in most of the cases you will find in your exam is that your first point of attachment in the molecule will be the same. You will understand this statement later in this video, but you will find the first point of attachment to the alkene bond the same, but you have to move on and one step further. So you have to assign the priority on the basis of first point of difference. You don't want to look at overall a group, right? You don't want to look that okay, this group is looking bigger, so it has the highest priority. No, that is not the case. You must find the first point of difference. Wherever there is the first point of difference between the two groups, there you decide the priority. So there are two main points I told you. First one is the atomic number base priority is given. We have discussed this point in the previous video. And second one is the first point of difference. So you must remember this first point of difference. Okay, now let's move on to the first example. In the previous lecture, I told you when you solve the solve the example, you divide the molecule into two equal parts and then work on each part separately. So let's zoom this molecule a bit so we can write on it easily. So divide the molecule into two equal parts, assign them A and B. Now work on each part separately. So for the first part, here you see that on both sides this carbon is attached to two carbons, right? This carbon, it is attached to two carbons, but the top carbon, it has three hydrogens attached to it, right? So this is a methyl group. What is it? CH3. So it is like this. It has three protons directly attached to it. Whereas the second group, it is an ethyl group. Ethyl group, CH2, CH3. So it is attached like this. So this carbon, it is first attached to a carbon which is similar in both cases. But here in the ethyl group, this carbon, it is attached to two protons and one carbon. Take 2 seconds, pause the video and try to understand it in your mind. So let's try to understand this. That for the upper group, the carbon, it is attached to a methyl group. So the first point of attachment in both for the both groups it is the same, that carbon is attached to carbon on both sides. But the difference is at the second point, right? So this carbon, it is further attached to three protons, whereas this carbon, it is further attached to two protons and a methyl group. So this is the ethyl group. So this group, it will have the higher priority because it has further another carbon which is attached. So the first point of difference here in this case is the methyl group. For the first part, the ethyl group will have the higher priority as compared to the methyl group. So we will assign this as 1 and this as 2. On the second part, the B part, it is quite simple. The methyl will have the higher priority compared to hydrogen. So here, if you see that the two top priority groups, they are on the similar side. So this is a Z isomer. So the first one is the Z isomer. Let's move on to the second example. Divide the molecule into two equal parts. Assign them as A and B. Now, look at the first group. It is CH2 and then carbon, hydrogen, and then two methyl groups are attached. The top group. Whereas the lower group, it is like this. It is carbon, one hydrogen, and methyl, CH2 and CH3. So now try to look for the priority. The first point of attachment, the carbon is the same. However, for the group on the upper side, it has two hydrogens attached and one carbon attached to it. Whereas the group on the lower side, it has one hydrogen and then two carbons attached to it, right? So I have written the structural forms of these two groups over here. So you can see that this carbon, it has two hydrogens and one carbon attached to it, whereas the lower group, it has one hydrogen and two carbons attached to it. So it will be quite easy to assign the priority order, is that the lower group, it will have higher priority compared to the group on the upper side. Now let's work on the B part. Here you see we have quite different groups. So in the lower side, the carbon is attached to two hydrogens and a fluorine atom, whereas on the upper side, carbon is attached to NH2 and an oxygen. So I told you, you don't have to look for the size of the group, right? The repetition of the group, if you see, you will say that okay, this is a amide group and it has quite a lot number of heteroatoms. One is oxygen over here and nitrogen over here, so it should have higher priority compared to this. But this is not the case. I told you that you only assign priority based on the atomic number. So the first point of attachment, it is the same. Here it is carbon, here it is carbon. So the next point is that for the lower group, the carbon, it is directly attached to fluorine. Whereas in the upper group, the carbon, it is directly attached to oxygen on one side and nitrogen on the other side. So now you know which has the higher atomic number. Fluorine has higher atomic number. So this will be priority 1 and this will be priority 2. So you don't assign the number based on the number of heteroatoms or based on the size of the group and like that. You just assign the priority based on the atomic number and nothing else. So now to conclude, the two top priority groups, they are on the similar side for the case of this molecule. So which isomer it will be? It will also be Z isomer. So let's move on to the third example. Divide the molecule into two parts. This is A and this is B. So let's first solve the B part. So here the top group it is an ester and the lower group it is a carboxylic acid group. So let's write them in their structural forms. The ester group it is like this, and the carboxylic acid group it is like this. So you can easily see which has the higher priority. So here the first point of attachment in both it is the same. Both are attached to a carbonyl. Both are attached to oxygen through a double bond. Both are attached to oxygen on the single bond as well. So till this point, you cannot differentiate which has the higher priority. So the first step, it is the same. Second step, it is the same. Third step, it is the same. So you move on. You keep taking steps further. This is I told you that until you find the first point of difference, you just keep comparing. So after this, if you see that for the ester group, after oxygen, it is attached to a carbon, whereas for the carboxylic acid, the oxygen, it is attached to a hydrogen. So now you know which has the higher atomic number. It is obviously carbon. So in this case, ester will have the higher priority compared to the carboxylic acid. Now let's solve the other side. The first point of attachment, it is the same on both sides. It is a CH2 group. From the upper side, it is next attached to a CH and a CH3, whereas on the lower side, it is attached to another CH2. So now you can easily see the difference, which has higher priority. The first point of attachment, it is the same. The next point of attachment, it is different. So at the next point, the from the upper side, we have carbon attached directly to the CH3 group, whereas on the lower side it is attached to two hydrogens. So the upper side it has higher priority compared to the lower side. So here again the two top priority groups they are on the similar side. So this is a Z isomer as well. Let's move on to the next example. Divide the molecule into two equal parts, A and B. First, let's solve the B part. So here on the upper side, it is attached to a carbon double bond, NH, whereas on the lower side, there is CH2 and OH. Now, you can make mistake after seeing, you'll say that, okay, here there is one proton and here there are two protons. So maybe you will give priority to the upper group, but this is not the case. So again, I'm repeating, you must look for the atomic number. Okay, so here the first point of attachment it is carbon. In both cases, it is the same. The next is that for the upper case, the carbon is attached to a nitrogen, and for the lower case, the carbon it is attached to the oxygen atom. So now you know which has the higher priority, which has the higher atomic number. So obviously oxygen has higher atomic number. So this will have higher priority compared to the amine bond. For the second part of the molecule, so here we have a cyclohexyl group. Here we have a phenyl group. What is a phenyl group? It is a benzene ring. So remember for the case of the easy nomenclature and the RS nomenclature, which is used in the other type of stereoisomerism. Here, a double bond is considered as that a carbon is attached to that substituent two times. For example, what I am trying to say is if there is a carbonyl, for this nomenclature, you write it as carbon attached to two oxygen atoms, right? So if we have a carbon-carbon double bond, here you write it as carbon is attached to two carbon, right? So you must remember this. It is quite helpful if you try to use it if you are initially learning the easy nomenclature. Later on, when you will have practice, you will have no need to use it because you will estimate the priority in your mind very correctly. Why I'm telling this here because you have to imply this concept here in the case of the phenyl versus cyclohexyl. So for the phenyl case, if you look at the cyclohexyl ring here, the carbon it is directly attached to a carbon, another carbon, but here there is a hydrogen. For the lower phenyl group, it is attached to a carbon, another carbon. But here, as I told you, here is a double bond. But for the case of this nomenclature, you don't consider it as a double bond. Rather than you consider it that this carbon is attached to two carbons. Right? Try to understand this. Pause and try to understand that for the cases of double bonds, you consider that that substituent or that atom is attached two times. So rather than writing it as like this, we will write it in this form that this carbon it is attached to two carbons. So when you write it like this, you can see the difference in the priority. So for the cyclohexyl part, the alkene carbon it is attached to a carbon, two carbons and one hydrogen. Whereas for the phenyl group, it is attached to three carbons. So which has higher priority then? Obviously, the phenyl will have higher priority compared to the cyclohexane. So if you see now the two top priority groups, they are on the similar side. So this isomer will be a Z isomer. You just pause the recording and then try to clear the mess because it will get quite messy if I keep writing on it. Now I will suggest you that you should try solving these two examples by pausing the video and then look for the solution when I try to solve these examples. Then eventually compare your answer with my answers and see if you have developed some skill to solve the easy nomenclature. So if you have paused and came back, let's solve the fifth example. You divide the molecule into two equal parts. This is part A and this is part B. So now look at part A. For the alkyne, I told you this is written like this, but you should imagine it like this, that this carbon is attached to three carbons, right? So the alkyne, it will be like this. For the lower group, there is CH2 and NH2. So now imagine which will have the higher priority. We have used this concept in the second example. So I told you you should not look for the number of atoms or like that. You should look for the first priority or the first point of difference, sorry, the first point of difference. So here this carbon, it is attached to two hydrogens and one nitrogen. Whereas here this carbon, it is although it is attached to three carbons, but the nitrogen, it has higher atomic number, right? So the first point of attachment for this part, it is carbon. Both cases same. But the next point, you see in the alkyne part, it has three carbons, whereas for this part, there comes a nitrogen at the second point. So for this case, which will have the higher priority, this will have the higher priority compared to the alkyne. So let's assume to clear your confusion, let's say if this group was like this. CH2, CH2, NH2. For example, it was like this. And on the upper side, it was still alkyne part. So now in this case, all the nitrogen is there. First point of attachment, it is carbon. In both cases, it is the same, right? But for the next point of attachment, this carbon, it will have two hydrogens and one carbon attached to it. Whereas in this case of alkyne, it has three carbons attached to it. So now the nitrogen, it does not matter at all. See, so I told you you must look for the first point of difference. In this case, nitrogen mattered. Let's say if it was a question where the group was like this. So in that case, this nitrogen does not matter at all. So in that case, the alkyne part would have the higher priority compared to the this group. But here in our question, we solved and we gave the lower group the higher priority. The B part of the molecule, it is very simple. So this carbon, it is directly attached to two hydrogens and one carbon, whereas here it is attached to three carbons. So you just look for the first point of difference, and this alkene bond, it does not matter at all. So for the upper group, there's carbon, carbon. So first point of attachment, it is the same. The next point is that this carbon, it is further attached to one carbon and two hydrogens, whereas the lower group, it is attached to three carbons. So this will have higher priority compared to the upper group. So now if you see that both the higher priority groups, they are on the similar side. So this is a Z isomer. Even at this stage, I am also quite astonished after seeing that all of these questions, they turned out that all of the isomers were Z isomers. So I will leave the last question on you people, solve and comment the solution, and then I will tell and I will update with the solution later. So till then, see you in the next lecture. Allah Hafiz.